test run through the first example. I'm going to keep going. Since it's the first time we've kind of done this, you just need to make sure and pay attention to the highlighted words that you come across in the book. And I'm not going to make you make a vocab list, something like you might do in history, but you still need to understand those. And so if there's any of those that you read and it's a little bit different, then that's something that I would add into the notes on top of what I have already given you. All right, so as we move under example 1 here, again, we're on page P4, you're reminded of how the quadrants are written in or on the XY plane. So if I just have an XY graph right here, okay, quadrant 1 starts up here in this top right part. This is where the X's and the Y's are positive, and then we head this way. We go to quadrant 2, we come down here to quadrant 3, and we end up in quadrant 4. In quadrant 4, both the X's and the Y's are negative. And so that's kind of how it goes. You've obviously got some notes right there that you can follow. So this next example, example 2, says, name the quadrant in which this certain point, they use capital letters for points, but it says point T is negative 8, 5, and we want to know where that's located. Well, even on this graph right here, if I know that, all right, well, negative 8 on the x-axis is left 8, 4, 5, 6, 7, 8, and I know that 5 on the y-axis is up 1, 2, 3, 4, 5. I'm just counting by 1 right there. That's where my point is, and we can just say, hey, at this point T of negative 8, 5 is located in quadrant 2. That's very, very simple to do, and don't make that harder than it is. So we're going to keep going down. Underneath example 2, it starts showing how we put relations together. In math, relations are just numbers that have something that they share. In this instance, we're dealing with ordered pair. And so when you get an ordered pair coming down here, there are really 4 ways that we look at this. We group them together by ordered pair. We can put them in an XY table. You can see them listed here, and they just took the ordered pair, 1, 2, and put it in the table. X is 1, Y is 2. They did that for all 3. Okay, you know you can do this on a graph. Each ordered pair represents a point on that graph, and you have your 3 points there. We've got 1, 2. We've got negative 2, 3, and 0, negative 3, just like we did listed as ordered pair or as it was put in the XY table. The other thing that's a little bit different but not hard is this mapping, and all we do is write out the domain and range. So the domain was the X values. It was negative 2, 0, and 1, and you can even see here they didn't even write it in that order. They just wrote it in the order it was given. The range is 2, 3, and negative 3, and then all you do is you draw an arrow connecting the X to the Y that it was paired up with in the ordered pair. So that's very easy to do. I'm not going to draw those out. That's something that if you're struggling with, then raise your hand and ask me for help, and we can do. Now, we're about to get more specific. Right here at the bottom of page P4, it starts talking about functions, and a function is when numbers specifically go together for some certain reason, and we're going to go up to the top of page P5, and we're going to start putting some of that stuff together. So now we're looking at example 3. And it says, state the domain and range for each relation, then determine whether it's a function or not. All right, and so I'm going to teach you how to do that. It's very, very simple. All right, so in this first set of numbers right here, they list it as ordered pair. And so the first thing that we're going to do in part A is we're going to write out what the domain is. Remember, the domain is the X values. I would say the proper etiquette is going from smallest to biggest. So if you look at these 4 ordered pair, the smallest X is negative 8. The next biggest X is 6. The next one's 7. And the next one's 10. 4 X values make up the domain there because that's the 4 ordered pair that they gave us. We're going to do the same thing for the range. We're just going to do it as Y values because that's what the range is for this relation, which we're going to see in a minute if it's a function. So again, we start at the smallest Y value out of my 4 Y's. The smallest one's negative 9. The next one is negative 2. The next one is 3. The next one is 4. We close it off. Now in this instance, again, each domain element and each range element was unique, and so we had to write them all in. So here's kind of how this works. As long as each X is different, if there are 4 ordered pair and we have 4 values in the domain, then we are going to say that yes, this is a function. I just put yes, comma, function. You can obviously abbreviate. I know it's coming off the screen a little bit. I'll move it over so you can see it. You can just put yes function, and you can abbreviate that from now on because I'll obviously know what you're referring to. Now let's go to part B. They gave us an XY table, and they want us to do the domain and the range. And now you'll see in the table something different happens here. In this instance, that looks like 3.4, but it's 3, 4. They put 2 values in. So when I go set up my domain and my range, I've got to pay attention to that. Now the domain is pretty simple here. I'm just listing these X's out. And in order from smallest to biggest, that's 1, 2, and 3. Close your bracket. All right? When we get down here to the range, we've got to understand that the way they wrote it changed. And so I actually have 4 range values here in the table. You will also notice that that the number 4 is shared. So I'm not going to write out 4 numbers even though I've got technically 4 range values here. So my range is going to be 3, 4, 7. Notice that I did not write the number 4 twice. You don't repeat domain or range values if you're writing them out. Now it wants to know, is this a function or not? And the best way that I could, the best example I could give is kind of the traditional sense of marriage. In a marriage, obviously, one person is married to another person. And so in this instance, if X is married to 2 different numbers, so this X is 1 and it's married to 3 and to 4, that would cause some dysfunction in that family, I would imagine. So since X has 2 different Y values, or X is not strictly unique for one Y, or another way to say this is each X has to have 1 different Y, then I'm going to come out here and say, no, this is not a function. Not a function. You can just write it out. Obviously, you'll be picking that from multiple choice situations, and we should be okay. I'm going to flip this over, and I'm going to keep on going. We're going to get down to example 3C, all right? And now they've given us a mapping. And so in this mapping, I generally, when I get a mapping, I will write out the ordered pairs so we know what we're dealing with. So remember, the domain is the X's, and the arrows are going to point at the range that corresponds to that X. So I know I've got the ordered pair in this relation of -3, -4. I've got 0 going to -2, but if you'll notice, I've also got 0 going to 0. So if you learned anything in the last problem, right now we know this is not a function because this unique X has 2 different Y's. Say, hey, each X has to be married to 1 Y. It's not happening here. So when we answer this in a second, that's not going to be a function. I'm going to keep writing these out. 1's going down here to 2, so I've got another ordered pair of 1, 2. And then the 5 is going with 0, so I've got the ordered pair 5, 0. Now, the fact that the Y's are the same mean absolutely nothing. When we talk about domain and range, and then we try to tell if it's a function, we're only doing that from the perspective of X. But we already said, hey, the zeros right there, the same X as 0 has 2 Y values. That's going to make this not a function. So when we go write out our domain and range, pretty simple, we're just going to list the X's that we used. There were 4 X's from smallest to biggest. It's -3, 0, 1, and 5. And our range, we're going to use those Y values. Smallest was -4, then -2, 0, and 2. Again, the range value 0 was used twice. The domain value 0 was used twice, but we do not write that twice when we're listing out the domain and range. And again, hopefully you caught on. This is not a function. Let's go to example 3 still, part D, and we're wrapping this up. Okay, they give us 4 ordered pair. I think the easiest way to do this is to go write out what those ordered pair are. So remember, check your dots, see where they intersect the grid of the graph. X's go left and right, Y's go up and down, and we're going to go from there. So if I start at the origin, to get to this point, I go left 1, so that X is -1, and I go down 1, so the Y is -1. For this point, I didn't go left or right any from the origin, so I'm at 0, but I had to go down 3, so that gives me the ordered pair 0, -3. For terminology's sake, that would be the Y-intercept of this graph. Let's keep going. This one goes to the right 1 unit from the origin and did not go up or down at all. So that's our x-intercept, and it's found at 1, 0. And then the last one's out here at 1, 2, 3, 4, and then up 2. That ordered pair is an x of 4 and a y of 2. So there's our 4 values that we had from that graph that we wrote as ordered pair. Now come right out the domain. Pretty simple. It's easy to do it from a graph. The domain is going to go from left to right, smallest to biggest, because that's how x's work. The further left you go, the smaller the number. The further right you go, the bigger the number. So our domain here is -1, 0, 1, and 4. All right, range kind of has a pattern like that, but the smallest range value is going to be the bottom one, and then the numbers get bigger as we go up. And so the smallest range value is -3. Then we see -1. Then we have a range value of 0. And then we have a range value of 2. Close it off. There you go. Domain and range is pretty simple. Since we only have 4 points and we have 4 unique x values, this is a function. And so that's kind of our first lesson. However you take notes, we're going to talk a little bit about Cornell notes and some of the things that we can do to really make sure that we're keeping on top of this. What I would definitely do as you start this is make note of, hey, we're starting off in Chapter 0, Section 1. This is going to be that first page of notes that you're going to need. Remember, you can use notes on quizzes and on tests, and that's something that is going to be very, very beneficial for you. I will be walking you through how we do this. Hopefully, we can find a way to make sure that you can see the book and etc. Like I said earlier when we started on the other one, on the other example, there's a class set of textbooks at the back, or you can go look up page P5 right there on your ebook that you should all have access to. And if you don't remember how to get there, then I will be more than willing to show you that. I appreciate you paying attention. Make sure that if I write it down, you're writing it down, because it's something that you're going to see and you're going to be responsible for on some form of test at some point coming up when we get to that. Thank you for your attention.